GATE is a competitive examination conducted every year by 7 ISPs and 1 IS. In total, 8 organizations conduct this examination every year. With this year, IIT Guwahati is conducting. So moving on, seeing the great organizations conducting this exam, let's discuss the topic that we'll be discussing today. We'll be covering angle modulation and demodulation, spectra of AM and FM. Not AM. AM I have already taken up in my last video. This time, spectra of FM. Okay, this will be the topic of discussion: angle modulation, narrowband FM, wideband FM, and phase modulation, demodulation, spectra of FM, phase log loop, and gate questions. The instantaneous frequency and phase. Before calculating what is an FM signal and a phase signal, we must know the instantaneous frequencies and phase values, how to calculate them, how to get from an PM signal an instantaneous phase frequency, and from an FM signal an instantaneance phase. So we have already known that phi t is AT cos phi t plus theta. But here I have shortened this expression and used a constant amplitude because the amplitude is not variable in frequency and phase modulation. That used to be the case only in amplitude modulation. And then theta t. Yes, in this case the frequency, the phase will be variable. So if we take the instantaneous phase, we can calculate it by minus omega t minus infinity to t omega a. Okay. Now this is the formula to calculate phase. So the phase would be omega ct plus k mt. The instantaneous frequency we can get by differentiating the phase, and we get omega c plus, with the dot I have shown that it's an differentiation, where k is the frequency deviation. In the linear modulation, the information was present in the amplitude of the message signal, whereas in angle modulation, the carrier frequency component of an FM wave contains part of the message information. Okay. So in this case, it is the carrier wave itself, the zero crossing of the carrier waves, I must say, that contains the information. A basic PM signal expression would be phi t a cos theta t. The instantaneous phase in this relation would be omega ct plus kp mt, and the instantaneous frequency can be calculated by differentiating the phase. An instantaneous frequency expression would be omega it is omega c plus af mt, and the instantaneous phase can be calculated by integrating the instantaneous frequency expression, and we get this final frequency modulation FM signal, which the M of alpha, the message signal, is actually the integration and added with the carrier frequency. Now this is a very important method, term-less direct method, where in first case, if we wish to have a frequency modulator, then what we do, if we integrate a message signal and pass it with a phase modulator, we'll get a frequency modulator. And if we differentiate a signal and pass it to a frequency modulator, we get a phase modulator. That is important and crucial to remember. Now let's look at the 2017 question. It's very interesting. A modulating signal given by xt, pi sine 4 pi 10 to the power 3t minus 10 pi cos 2 pi 10 to the power 3t volts is fed to a phase modulator with a phase deviation kp 5 radian per volt, and if the carrier frequency is 20 kHz, the instantaneous frequency at t equals to 0.5 milliseconds. We need to calculate instantaneous frequency. The formula for instantaneous frequency, we have already known that if a phase deviation is given, and you'll see that this whole function, if we take this as phase, then if we integrate this, like we differentiate this phase, okay, if we differentiate this phase, we will get m and then multiply with kp, okay, and then multiply with kp and add the omega c value, we'll get our instantaneous frequency. Okay, so let's start. It's given that kp fc, we know that instantaneous frequency of phi is fc plus kp by 2 pi. 2 pi is mentioned over here because of being converted from radian per second to just per second, and differentiation of mesosecond. Now differentiate mt with respect to t. We get this whole expression with the help of product differentiation. Okay, at 0.5 millisecond we get this value, and on substituting different values into this equation we get our final 70 kilohertz value. Okay, a very simple, very easy approach to find instantaneous and phase of a signal. Okay, now let's go. If you say the power of the angle modulated signal is a square by 2, it is almost remains this throughout, because you can see that the amplitude is not changing. Amplitude is remaining the same, and amplitude is the main parameter on which the power of the signal is considered. Okay, so here I have shown you an AM signal frequency band. To recall that what we have learned is this. This is a double sideband with the x of t expression, this. But a narrow FM is very similar to AM signal with a small changes, that if you put all this value, right, beta is equals to sine omega m, you will notice that the magnitude at omega c minus omega m frequency is negative, with a reverse amplitude at fc minus fm, rest is all the same like that of the AM signal. So this is a small change that we find in a narrowband FM spectrum. The wideband FM spectrum. The expanded FM expression x of t is a by 2 cos mt cos omega ct minus sin mt sin omega ct. If we put the value of mt, we'll get this whole expression. Here I've used a Bezel's function with n order and argument beta with x of t, and substituting the value. This is the expression. Remember this expression. Okay, it is quite important, this one. Now let's look at the properties. The properties of Bezel function is j of minus n beta is minus 1 to the power minus n j n beta. Like it gets reversed from j of minus n beta to j n beta. X of t is j n beta cos omega c plus n cos omega m. The FM spectrum consists of a carrier frequency 9 plus infinite number of sideband at frequencies fc plus minus fm. All lines are equally spaced by the modulating frequency, and the odd order lower sideband are reversed in phase and inverted related to the unmodulated carrier. This happens with only the odd order lower sideband. Okay. Now the basis function is 1 upon 2 pi minus pi to pi e to the power jx sine theta minus m theta d theta. These are the very important properties of Basel function. As the number n increases, Jn x decreases. That means J0 x is the maximum value. I have already talked about this, how to convert from a negative n value to a positive n value. Jn square beta is 1. Jn beta always result in real value. Now consider this example. Consider a tone modulated FM or PM wave with FM 10 kHz, beta 2, AC 100 and FC 30 kHz. Write an expression for FT. Draw a spectrum line, beta 2 and show there from that ST is less than A square by. We know the instantaneous frequency omega I is omega C plus Kmt, where mt is A sin omega mt and d by dt is A by omega m cos omega mt. Omega I is omega C plus K am by omega m cos omega mt. Fi is fc plus K am by fm cos omega mt. Beta is modulation in Kam by fm, where K is 20 kHz. And if we substitute these values, we'll get instantaneous frequency as 30 plus 20 cos 2 pi 20 pi t. If beta is greater, it is a wideband signal. Okay. Now for wideband, we have already known this equation, and beta is kfm. I would suggest you to kindly pause this video and look for a second how I have done, because this is the correct method. You won't get it anywhere. I have done it personally by myself. So have a look at it, understand it, clear your concept, and then move forward. This is again the line spectrum and shown all the possible magnitudes. Okay, have a look at it and you will get all the answers. If you have any query, comment below in the section so that I can get to know and clarify your doubt. Moving forward,